Day 2 of the Law of Signs. The reason I split this lesson up into 2 days is because today we're going to review the ambiguous case, which is a little bit challenging for most people, and we really need to focus on some particulars about this sign law and solving the triangle. Now, some of you guys will find this chart very useful and others will find it very confusing. So you will have to assess if looking at rules and memorizing rules, such as the ones that are identified in this chart, will be helpful or not. I will emphasize the key rules whether you need the chart or not. Now, we're looking at triangles. We're looking at the lengths of the sides and the angles. In the last lesson, we were very, very specific where we were looking and solving triangles that were given 2 angles, and then the third angle we could deduct from subtracting those first 2 angles from 180. This case is a little bit different because we are only given 1 angle. So in each of these, we're only given 1 angle. It is identified as an SSA triangle, or often I like to call it an ASS triangle, which is not the nicest of words, but as you will see, these questions sometimes are a pain in the ASS. Okay? So, now, I'm going to just leave this chart here. You can refer back to it as I'm kind of going through some different rules and see if it's useful to you. So I'm going to move forward. First question. We're identifying what information is given to us. So as you can see, we have an angle, we have a side, and we have a side. So this is going to be our angle, side, side triangle. Now, when we're given an angle, side, side triangle, the lengths of the sides are very, very important because we need to determine if when we find the angle between the 2 given sides, is this an angle that will create a triangle? If I kind of do this, so we have 110 degrees. We have this as 8, and then we have this length here as 11. Now the question is this length of 11, is this a long enough length to reach all the way over and connect to the side? Well, it really depends on what the angle is here, because if I change that angle and I make it smaller, well, as you can see, now this is not drawn to scale, but as you can see, the length of 11, which is a fixed length because it was given to us in the question, is much too long to attach and create a triangle. So let's rotate this angle to the right a little bit. When we do that, now the angle is larger, but the 11 can actually reach the other side. Well, what if the angle was so large, and I know some of you guys, I've already lost you, but just bear with me. What if that length is so, the angle is so large that the 11 doesn't even reach that other side? Well, then we're in a situation where we have no solution because we can't actually create a triangle. Now, we're going to look at cases where we have no solution, meaning that that length is not long enough to reach the other side. There's one solution where it's a perfect length to attach at one specific spot. And then comes our ambiguous case. 2 solutions. I'm not going to jump into that right now. So let's go back to this question. Again, the instructions are just saying solve the triangle. So we look and we are given a matching pair. We're given angle Q, side Q. So what we're going to do is we're going to use our sine law. That's what we do when we have a matching pair. We don't have any information on P. So that means we have to find N, angle N. So I'm going to make sine N over lowercase n, sine Q over lowercase q. I'm going to sub in what I know. Sine N stays in the numerator. Remember, I put the angle in the numerator because that's what I'm solving for. 8 equals sine 110 over 11. I'm going to cross multiply. So I multiply both sides by 8. Those cancel. And I'm left with, I'm actually just going to go to the next side. I'll come back to that in a second. So I'm left with sine N is equal to 8 sine 110 degrees over 11. I put this into my calculator, and then I'm finding an angle. So that means that I'm really finding the inverse sine of this relationship. And when I do that, I get 43 degrees. So if I go back to my triangle, I now know that this is 43 degrees. So here's the rule. I'm going to look at the angle that I'm given. This is identified as my adjacent side because it's attached to the angle that's given, and this is my opposite side. So I'm going to put opposite and adjacent. The rule is that when you have one angle, so it's an ASS triangle, and the opposite length is larger than the adjacent length, there will always be one solution. Let's go back. Now we are looking here. Our original angle that was given was obtuse. It was 110 degrees. In this case, my opposite, and here's my adjacent. If the opposite is greater than the adjacent, so A is larger than B, we have one solution. That is the rule. So as I said, this chart may be helpful to some of you guys. I'm going to go back here. Now that I found 43 degrees, I can now find my remaining angle, which is angle P. To find angle P, we have two angles now. So we can use 180 degrees minus 43 degrees minus 110 degrees. When we do that, we get 27 degrees. Now we have all three angles, we have two sides, we have one remaining side, which is the side P. So we use our sine law. We cross multiply. I'm going to plug in P, which is 27. We have 11 sine 27 degrees over sine 110 degrees. We put that into our calculator and we get 5.3. Now we've solved our triangle. Now, some of you may be thinking, what was she talking about at the beginning, that we just solved a triangle? Well, it was simple, but the key here is assessing how many triangles could possibly be formed based on the information that's given. Let's try another one. The first thing we're going to look at, solve the triangle, given two sides and an angle. Well, if we're given two sides and an angle, it's our ASS. So here we have 52 degrees. We have an opposite, so we have that matching pair. Now that matching pair means that we have to use the sine law. And then we have our adjacent side. So here's adjacent, here's opposite. And remember, those are always labeled in relationship to the original angle that's given. So the first thing what you have to do here is you have to assess. I have an angle, and I have an opposite side, and I have an adjacent side. Therefore, my answer could be no solution. So meaning that this 5 is not long enough to reach all the way down to hit the length of D, because we don't actually have a fixed length of D yet. So D can be really short or it can be really long, and we don't know that. This angle D could be very wide or it could be very narrow, and we don't know that. That's why we don't know if this length of 5 is long enough to reach here. So as soon as we recognize that the opposite is less than the adjacent, we go back to our chart. The original is acute, and our A value, our opposite, is less than our adjacent. Here are our options. We either have no solution, so that length is not long enough to reach, or we have 2 solutions, and this is our ambiguous case. When we have 2 solutions, that means that A was long enough to reach here, but then if we change the angle at this top here, and I like to call this our pivot, if we change this angle, because we don't know if this is a large angle or a small angle, what you'll see is that this length of A can actually rotate in and create another triangle. How cool is that? Again, I know some of you guys, I'm losing you here, and you'll get it when we practice it. Just bear with me. So now we've assessed our triangle. We understand that we're either going to have no solution or 2 solutions based on the fact that our opposite is less than our adjacent. Now that I've assessed that, I just kind of keep it in the back of my mind, and then I just use my sine law. Well, I can't solve for D because I don't have an angle and I don't have a length. So that means I must solve for this angle here. And let's call this F. So angle F, sine F over lowercase, which is 9, and sine E over E. So I plug in what I know. I'm going to cross multiply. I've written it out already. We cross multiply, and then to find the angle, we take the inverse sine. So we get F is equal to, and our answer says error. And what that means is that the length of 5 is not long enough to reach down here and actually create a triangle. So we say no solution.